All right. Is there anybody still at the coast? Okay, good. Just making sure I can't see y'all. All right. So this is the project from last week. I told you this was kind of a tangent from last week, where we tried to implement what I'm going to implement right now using scripting. That was right here. So um, we have our. I'm just going to close this, and we have our weed diffusion model, which did work. It worked just fine, um, and so we have that available, and we're going to implement this as a script in the what's called the Python window, which is right here. Okay, but before we do, I just want to demonstrate that Python can do lots of things inside of ArcGIS, including automating this temporal modeling process. But really, we can execute any tool, and I think maybe I already showed that on the first day, but just in case, we can use Python to run any of the tools. So calculate field. Oh, arcpy. Oops. arcpy.cal. I'm not spelling anything. Calculate field has got to be in here. Calculated field management. And then you can specify the inputs and it'll run. Okay, just so if we wanted to add another field to new states, then we could specify that we're gonna specify, well, not add a new field. This just calculates a new field. So we could run that. This would be the exact same as running calculate field over here. So this is the input table is the first parameter, Python 3 there. It looks like the parameters aren't in the same order. I'm not sure why, but that's there. Then the field name is the next parameter here, and so on. So you can run a tool right inside of Python. Okay, so seeing that, you may say, what's the big deal about scripting? Because I can already punch all of those values into the GUI, and it's a lot easier to see what I'm doing in the GUI than it is in Python, and that's true. Okay, but what makes Python a better way to do it is not, if you want to just go through a workflow where you're pressing the buttons, use the GUI. Okay, don't use Python to supplant the GUI. That's not what it's for. What Python is for automating tasks and being able to do something repeatedly, because it is a full programming language. In the class next semester, we actually cover what that means, but it's capable of doing anything that needs to be done with your computer system, in addition to being able to execute GIS statements in ArcGIS. Further, it's also capable of doing computations, any logical or mathematical computation that you wanted to do. It has a reference, a language for interacting with the computer to do any computation, store any data type that you need to do. So you could use it to couple, or to basically take one process and glue it to another process. And so what we're going to demonstrate today is its ability to loop through and execute a particular command multiple times, but that's only the beginning of its abilities. And so we could we can derive, any number. We can store different data types. We could then use that to ingest data from a different program. So let's say ArcGIS didn't ingest by default, like and as long as we can read it, then we can get it into GIS. So it can be used for lots of different purposes, and it's not just raster data either. Okay, we talked about this course is focused on raster GIS, but ArcPy or Python will allow us to interact with any command in the GIS software package. And Python is not, by the way, I don't know if I explained this before, but it's not part of ArcGIS. This is something that ArcGIS actually adopted because it was so popular in just the general data science world. And so the course, we spend the first 3 or 4 weeks just focused on learning the language and the logic, and then we spend the rest of the semester implementing GIS routines with it. Okay. ArcGIS recently announced that they're going to, that they have, they've already implemented this, but this is kind of a cool side note here. So Jupyter notebooks are a web-based interface to Python. And so ArcGIS will support this web-based web-based version of Python as well. So you can create a brand new thing, and you can execute Python statements right in this web-based code. You can run little snippets of code in these code blocks. That's what these are called. And then you can actually tie it in with regular HTML markup. So this is something that we're going to get into a little bit next semester. So it's a great tool for sharing results where you have code live. So if somebody wanted to tweak your results a little bit and they knew about Python, they could do it. But you can, import ArcPy right inside there, and then you can run it. So I'm just proving that now this is a different this software package was developed totally outside of ArcGIS, but as long as you have ArcPy installed on the computer that you're working on, you can execute these statements right in this web-based interface. So that's something that we will focus on a little bit next semester. I just got this feeling like, did I start recording? I think I did. Yes. Why does this say 2? I don't know. Maybe this is just keep recording from the first one. I don't know what it's going to do. We'll find out. Okay. So that's that. Sorry, I didn't mean to not answer your question. So, but most of it's recorded on the "what did you miss" question. There.
Actually, asking him.
Oh, okay.
You were busy, but I'm glad I got to talk to Dave at all.
Oh, yeah. Cool. All right. So that's something that I'm excited about. Okay, so we're gonna implement. So really, the first thing that we need to do, we see that we can access any of these tools that are already there. Okay, but we can't type in arcpy weed diffusion, right? That doesn't exist inside of ArcPy there. Okay, so go back to geoprocessing. Here we've got our toolboxes. Let's make sure that it's there. There's my temporaling model. Where did I save that on disk though? I don't know where I saved that. There it is, right? Okay. All right. Now, you see that I just executed a simple line right there. I could also say, you know, X, just like a programming language. If you haven't taken a programming course, that's fine. But you can execute a Python line by line like this. And so I can print X. You do have to know some of the syntax, like how did you do that? But you can also you can you can open up Notepad, and I could say, you know, X equals 10, and then I could say print X, and then I could copy multiple lines into Python and then hit enter twice, and it'll execute all the lines. So you could write a script in an external software package and then implement there. There are better software packages to write your Python in. So Notepad will work. Notepad++ will be better because it'll symbolize it correctly. And then almost all computers that have ArcGIS installed will have installed this IDLE software. And this brings up another Python interpreter window. And if you say new file, then you could also, like I could say import ArcPy here and print, X equals 10 and print X. So it basically will turn things different colors for you and kind of like fix some formatting errors, but nothing special. So those are both options to get those into Python. Now it used to be that you could do what I'm trying to do here. So ArcGIS Pro, execute custom toolbox. Python. All right. Okay, that's what you have to do. So I needed that syntax there. So in order to get my custom toolbox into to be able to be executed from Python, I need to run this command. And so what I need to know the actual path to my toolbox in order for that to work. Okay. So let's see if this works here. And so this is finding a toolbox. I don't know, but I can go into properties here and get the correct path. I guess not. Oh, if I hover over it, I get the. There we go. No. See how I hovered over it? There, right there. That's the correct path. That's a pretty convoluted path. So I see that it's in that long path. Let me. I also have this other version. Oh, yeah, that's a different version. Let's see if I can access it at this other location. But if I wanted to, I could find it in that other. But this one's the one I just downloaded. So this might be easier for you to get anyway. So I've got it in downloads. And let's see if I add that path, if it'll work. So I'm going to cut and paste this value. Python does not like the slashes to go this way. So you have to change your slashes back to this direction.
You have to double them?
Or double them.
Or double.
Yeah.
Okay.
Or, another or, so you could double them like this, that'd be fine. Basically, the slash is an escape character, and so you're escaping out of it being an escape character. The last option is to put a little R before any quoted string. And if you do that, it'll tell it to ignore all the escape characters in a in an area. Now, I'm having trouble. Did you take the Python course last time? That's what I thought. Okay. So you remember all that.
I remember a lot.
So I only selected the path to the downloads folder, and I need to actually select the path to the toolbox itself. So that's what I messed up. And it'd probably be better to put it in a different place anyway. .tbx. All right, so now it imported that toolbox, and so now when I hit Arc Toolbox, I have my tool that shows up there. Your tool, like all other tools, your tool will always be denoted by the name of the tool with an underscore and the name of the toolbox. And what's kind of cool is when you try to run it, now you'll be given the reference to the precipitation data set, the temperature data set, the source data set, and whatever you're going to have for your new source. So let's test this to see if it works, because I'm a little bit worried because all the data is still saved under that GeoAdmin thing for me, and so it's pointing to all that. So hopefully your model isn't doing the same. So if it's not working, then that would be bad. But I can fix it. So I have to specify the locations of each of the data sets. And so one thing I could do that I think that I will do, maybe it's the bright sun or something. I'm sneezing a lot. Okay. Is to you can specify what's called the working directory, the current workspace, and in doing so, if I specify the current working workspace, I don't have to type the full path to the precipitation and the temperature data set. I can just specify the name and it will go there. Okay, so and if all this isn't making like complete sense, that's okay. So ArcGIS, sorry, ArcPy set workspace. I forgot the exact current workspace. Let's look for the syntax here. So arcpy.env. So now I can specify the location to my data, and it's right. I think it's in my data is in C temp, and it's in SA climate data. There it is. So that is the workspace that I want to work on. So I have to specify that data set, and I'm going to put a little R in front of it again to make it so that the slashes work fine. Okay. All right. So now if I go and try to run that temporal modeling, I guess I haven't run it before. If you ever want to run a previous tool, you can just hit up. So it'll go run previous tools. All right. So now I got to say arcpy.weed diffusion temporal modeling, and now I can start typing, and it should recognize anything in that directory. So if I say precip, I guess it does. Oh, quote I need it in quotes. I guess it doesn't, but let's see what the data in there is. Okay, so I'm going to start with, we'll start with precip 6. So I got precip _6, and then comma, and it's telling me right here that it wants the temp next. So I say temp, in quotes, temp underscore 6, and then comma. That's the next parameter. This is like a function. That's what we call it in Python. So now I specify the source. And the source here is, for the first time through, I want it to be new source or source. Source. Okay. And then finally, this is the output. And so I need to specify an output name. So I'll call this new source. And last week, we were just calling it based on the month it was running on, right? So I'm not, after I thought about it after class, and I was like, should we call this new source 6 or new source 7? Because this is going to be the source for the next month. Anyway, I don't think it matters as long as you kind of keep that in your mind, because this is what we're predicting it will be after that month is over. So I'll call this new source 6 for now. And actually, to me, it makes more sense to call new source 7. So 6 is, anyway, 6 leads to 7, and then 7 gets used as the source for the 7th month, and new source 8 is the output for the next month after that. Okay. So hopefully this works. Yeah, no, it's not working. So, wow. Tour environment weed diffusion not found. Should be able to find that, right? Hmm. Now this is a different toolbox, so let me see. See users, admin, documents, projects, temporal modeling. Let me see if I import the other tool, if it does anything different. Which I don't think it's, yeah, that's it right there. Huh. Yeah, I'm kind of puzzled as to why this isn't working here. Let's make sure this is still working. Yeah, that's still working, looks like. All right. C program. should work. Hmm. Yeah, that's just saying that it's not working, and it's basically saying that the tool isn't found, but it wouldn't even let me run it. You would think if it couldn't find the tool. Hmm. All right. Well, this may take a few more minutes, but it won't take significantly longer. So one thing that we could do is we could just run this entire model. I know that's not ideal. It'd be ideal to get this working here, but really, how many operations are we talking about here? We're talking about a conditional, divide, times, divide, and cost distance, and a set null, right? So all the yellow boxes. So 1, 2, 3, 4, 5, 6 lines of code. Okay, so this line of code would have let us run this entire model, right? But we can express this entire model as 6 lines of code. Okay, so that's not an extreme amount of data, and so we do have to pay attention to what the inputs and the outputs were again, but it's pretty quick to turn this into code. Okay. So let's look at this conditional statement. Actually, before we even start, let's think about what the inputs are for the model. Okay, you remember what the inputs are for the model? What are there's basically 4 inputs. One of them is actually specifying the output. What are the inputs for the model from last week? Yeah, the input parameters. Okay, sorry.
I think I've got source 6. I renamed it to make the iterative work.
You did.
So source on yours.
Does it work on yours?
No.
Okay. So what you do when you're building a Python script is you think about your inputs when you're building a whole script like this. So I've got the precip as one of the inputs,
right.
And I could say for now I could say precip underscore 6. Yeah. That's going to be the data set I need, and then I need temp. I need temp underscore 6, and then I need to have the source. Source. Is it CE or SE? And then new source. Equals, this is going to be the output, source, or, yeah. Actually, maybe we should stop calling them new source. Let's just call it source underscore 6 or 7. Okay. All right, so these are kind of like our inputs, and I've named them for the script, for the purpose of the script. Okay. Later, I'm going to add the loop. Okay, that's the only really new part that we're going to do. But I'm also going to take all of this data and all of this model and input it into 1, 2, 3, 4, 5, 6 lines of code. So I'm going to take the model. It'd be ideal to just run the model, okay? But it's going to be just as efficient to run it as a script. So, sorry.
Quote mark at the end of temp 6.
Yep. Thank you. All right. And so what I need to do is run these one by one. Okay, so we have this divide, right? Let's look and see. What we did was we took the precip and we decided after a while to divide that by 10. Remember, we did it a few different ways, but I was wrong the way I typed the lab up originally. But we divided that by 10, okay? So we can go down here and say arcpy dot, all of the spatial analyst tools are actually under a thing called SA. Okay, so arcpy.sa dot, and then you type the name, so divide. Is it divide right there? Okay, so then you put your two rasters in, and it will provide you a result. So I'm going to copy and paste this up there. So I'm just going to say arcpy.sa.divide, and then we decided precip by 10.0. And then we have to have an output. We have to have a temporary output for that. So I'll just call this step 1. And now we have to make step 1 equal something. So we could call this what did we make it here? We made it called speed. So I'll do the same thing. Call it speed. Okay. All right, so the next step is we take this conditional operation. So we can change this to con and look at the conditional raster. So let's look and see what that value is. That's 2100. Okay. So the conditional raster was temp. So what we do is we'll just call this step 2. Step 2 equals arc, well, copy and paste it. And then this is temp, comma, what was the next parameter? The name of the where clause? I think that's what it was. Oh, the true raster. Okay. So the true raster was true and false raster. What were they? False is 1, true is 0. So did I get those right? True raster is 0, and which order is it on here? True raster is 0. Okay, good. All right, and then this is the where value is less than 2000. Like that. So what this is going to do is execute that conditional statement using the same parameters. It's going to save it to a step called save it to a data set that we store in step 2, which I don't know what I called it here. I called it barrier. So I'll keep that consistent. Call this barrier. So now it's going to run and save it out into a new file called barrier. let's see if this works up to this point. I think I might have actually made a syntax error already, but yeah. It didn't create an error. That's good. It's actually not saving these here. It's saving them in memory. So we don't even need to actually refer to these. We could. I think the best way to do this is to actually change these names. So it's even better because it's just putting those raster data sets in memory. So that's awesome. That's the way we want it. Okay. And so now let's run this one and this one. Now it's time to run the next one, which is going to take is going to be times. Or sorry, .sa.times. It's going to be capitalized. Python is case sensitive. So if I go step 1, comma, step 2, does not exist or is not supported. Okay. Yeah. Okay. All right. So now it's producing those other data sets. So see, speed is produced. It's only a temporary data set that was created before. Okay. So it's producing these data sets as it's going through. So let's actually call this something. What do we call it here? Speed width barriers. So I called it speed W bars equals. Okay. And then another divide. Here we're dividing 1 over this. So that's easy. We can copy and paste this line. So we're going to divide this into 1 and call this, what do we call it over here? Friction surface. Okay, and then cost distance. Let's look at this. arcpy.sa.cost distance. Okay, so there's a lot of parameters there. See, we have to have the source data, the cost raster. Those are really the only ones that are required, and they may be the only ones we use. I forgot a little bit since last week. So we got our source. We've got our friction surface as the cost raster, which is the second parameter. And then we have the output as travel time. So yeah, I think that's all we have. So we're good. So just take this. So the first parameter is the source data, source, comma, and the second parameter is the friction surface. Just make sure I didn't spell friction wrong. So there. And so this is the travel time. And then finally, the set null. Anybody remember why we do the set null here at the end? Why did we do that? What was this process doing? So what did the previous step do? The cost distance. What's the output of every cell in this travel time? That's a clue. Produce.
you set the cells to null if they weren't reached within a month?
Exactly. Good job, Michael. Right? Was that Michael?
Yes.
Thank you. All right. So let's see. So travel time is the input here, and then I got to find out what the other variables are here. Travel time, the false raster, where clause. Okay. Inconditional raster, false raster. So the false raster is this is 0. Okay. So 0, and then the where clause. It wants the SQL where clause. Like that's the other one just gets turned into SQL. It just doesn't tell you. It's like the GUI turns this value into this value, and so that's what Python wants is that. Okay, so we're going to call this new source. Here, I'll call this. Yeah, I'm going to call this NS just for now because it's actually going to save that out here, and so there is actually. It's been doing all this in memory, which is good because we don't want to have to save out all this temporary stuff. That's one of the weaknesses of Model Builder is you have to like specify it and things like that. Specify where it's going to go for each step. You can specify in memory, but by default it saves it all out on the disk. But there is a way to. I forgot it off the top of my head real quick. So. ArcGIS Pro. When you want to save the final output, you have to actually explicitly save it. Raster save Python. Okay. All right. It's just called save. Yep. Okay. Permanently saves the raster data set. I thought it was capital, but I guess it's not. Yeah, there it is. I guess it's not capital. Okay, so we need to put that in our script. And we're going to save out NS as new source. So whatever's in new source will get saved out as NS. Okay. So now this script should work. It only still represents one iteration, but you know that I basically did a little bit more work than I thought we would do. But now you get to see a little bit of what Python scripting is all about. Okay. So basically we implemented this model, or I implemented, and y'all followed along or watched. I implemented this model as code. So these are equivalent. This should produce the same output. So I want to test it and make sure that it did. So I'm going to run that over here and see if I have any errors. So it's running through here, and let's go back to the map. So that's the speed. Let's see if is this the right place? So C temp SA climate data. Is this the right climate data set? Hold on. C temp SA climate data. Because it's not. There should be another data set called source. Where to put this one? So it is actually writing these kind of to disk. This is the in-memory workspace here. So it's interesting that it got here, but Why isn't it doing? Oh, temp6 does not exist. Temp6 does exist. Okay. Temp6. I'm going to just explicitly state where these guys are. Just going to make sure that they're actually stored in these locations. Okay. So now, let's see if this works. Remove. So it's a little more promising. Yep. See how it produced all those really quickly? It produced NS, travel time, friction surface, speed bars, barriers. It produced all of those data sets for us. And if I look at the properties here, it even saved that as source 7. So now I have that value. If I refresh, this guy over here, I'll have source 7 now in my data set. Okay. All right. So now we know that they're equivalent statements, and I could do the same thing we did last week, where I manually modify this. So I changed this to 7, and I changed this to 8, and I changed these two to 7, right? And then I don't even need these statements anymore. I could copy and paste this in there, double click, and it'll run again. And this time, it will produce the next step. Okay, so now it's recalculating all those variables we just calculated, and it's bigger. Now you might say, well, it overwrote the other one. It didn't. It just took that layer that was named the same thing and put it there. So if I want to add back source 7, I can. So now I've got source 7, and it's a little bit, here I'll zoom in. It's the way it should be. Okay. So in my script here, what I've done is I've modified these values. And so if I want to then run this multiple times, I have to insert a loop. And Python, like all other languages, has a specific method for creating a loop. And that method is to use this syntax. You say for, and then you say you come up with a variable. We're going to say month, I guess, in range, and then you specify a lower range and an upper range. Okay. Now the math here is going to get not tricky at all, but remember we're starting with 6 and we're going all the way back around, right? I'm going to do this real quick. Let's get our months working right first, and then we'll put it into our other script. So let's say we want to go from 6 to 20. How many months is that? What's going on? Print. Okay. So you might not know all the syntax for Python, but this syntax should, we're just going to call this month test.py. This should iterate through those values. Yeah, or wherever you want me to save it. I want to call it .py. That means it's a Python script. So now I'm going to run this guy and see how it goes. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, right? So I'll go from 6, 7, 8, 9, 10. Well, what happens when I get to 13? What should I do? I should really be using what number? 1. Yep, good job. So I'm going to come up with a new variable called like real month or something. I don't know if that's a better name for it. If there's a better name for it. Real month is going to equal, is going to have to equal 1 if it's over 13. So anyway, how could I do that mathematically? How could I change a 13 to a 1 and a 14 to a 2 and a 15? Yeah, so I could say is equal to month minus 12, right? But only if over. Okay, so then I need to do an if statement. And so computer programs are great. One of the reasons why scripting is kind of cool is they're great at logical problems like this. So if you said if month is greater than 12, then do this. So this is just the syntax for an if statement in Python. Else real month is equal to month. So now we're going to print the real month. See how this works. Looks like that works fine, right? 6, 7, 8, 9, 10. So we're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 months. That's more than I said to do. We're going to get 14 months. Okay. But that'll work great. Now, what if I did to 30? No, would this work? Is that going to work? It's going to get up to 15, 16, and 17 down here at the very end, right? Or sorry, 13. 13's bad, 14's bad, 15. All those numbers are not going to work. There is a way to do it. So I'm going to comment these lines out. So commenting is another thing you can do in most programming languages. And you could say x equals 12 divided by, comment this out too. Actually here, we'll just do this in steps. Control C, Control V, whoops. 12 month. This is a different operator. So you're familiar with add, subtract, multiply, and divide. This operator is called the modulus operator. So run that here. And let me do that the other way around. Month 12. Okay. What the modulus operator does is that it returns the remainder when you do a division. So what we're saying here, I did it wrong the first time. So we're taking the value in this iteration, and when it reaches 13, what happens is you do 12 divided by 13 is equal to 1, and the remainder is 1. The only problem is it's also turned 12 into 0. Okay, so we're close, but we still need to modify this a little bit to get us to the right value. Okay, so one thing we could say is, well, one thing we could do is just say that it's the whole thing plus 1, right? That'd probably be the easiest solution. And then we just need to realize that in order to start our particular problem, we need to start a month earlier than what we're actually getting to. So now it works. Look, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, and it would just keep going. So now we're going to get a consistent stream of numbers. So we can do this now for as many years as we want. We could just up the number of months here, and it'll keep going, and we could find out where this will get over time. All right. Now, the only problem is if we want to save these intermediate results, we're going to have an issue, right? We're eventually going to be saving over our results. I mean, we're not going to be able to see. We're not going to be able to see the last, like, you know, in other words, if we save 2, then it'll get overwritten here as 2. So we might want to save the month. We might use the month variable to save how many months have gone by in total, but use the real month variable to store the precipitation and temperature. Okay, you might be saying what is he talking about? But let's just implement that here real quick. So we're going to pull all this stuff over into this test data set and just put it, just paste it in, and then we have to implement indent. That's what Python requires. So now all of this is inside this for loop. Okay, so we can modify this data set a little bit to get what we want. And so this is what I'm talking about. So here at the end of this, we always want this to be the real month. See what I'm saying? So we're appending on the real month onto the end. So now when this runs, it's going to run lots and lots of times. Every time it runs, it's going to say the first time through, precip is going to be precip plus 7, temp plus 7. So it's going to put the word 7, sorry, the character 7 onto the end of this. That's what this is. It's basically turning this into from a real number, it's turning it into a character, right? But this, on the other hand, we want to change to always be just the month. Why? Well, it's because if we don't, we'll overwrite all those other steps in the process once it gets to be more than a year. Okay? So our sources are going to be named source 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, all the way up to 30, whereas the data that it's being drawn from, the precipitation and temperature, are going to change. They're going to go through the cycle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. Okay? So we had to implement that logic in order to get it to work. I don't really want to make this run for 30 months because that would take forever. But we're going to do 20 for now. So if I come back over here, I don't know if there's a time limit on how long these, probably not, but I'm just going to delete all these just to make sure, these temporary ones, so it doesn't have any problems overwriting any of those values. Remove and remove. I really don't know if I had to do that or not. Probably not. Okay. So then I click this in and I press enter twice. I don't know why that 7 popped up at the bottom, but oh, it's because I have a print statement in my code. Now something stopped. It should be giving me errors, but it's not actually showing me the errors, but it stopped after the friction surface right here. Oh, maybe because there's no source 7. There is a source 7. Maybe it's not letting me overwrite. Let's try this again. Yeah, that was it. That looks, no. Friction service. Refresh. Source 7. Speed barrier, and it looks like it's the second time through the loop, right? Because it's got speed, barrier, friction, speed, barrier, friction. So, but it didn't print again.
All right, wait a minute, is your next one up?
Oh, so it should be +1 because you're right. See, so what I'm doing here is I'm trying to save the new source as the same as the old source. Thank you. So this should be +1. Good catch. Now I wonder if it will have a problem because maybe this source raster is all screwed up, but we'll see. Let me see what this raster looks like. Oh, no, that looks good. So this should always be new source +1. So still executing. Whoops, I didn't mean to get that last one. I'm just going to delete all of the data. So just have the USA on there. Okay. And see how many times this is running. New underscore source. I'm going to also have it print that to see if it even gets to that portion of the code. So it looks like it's dying before it even gets there. Friction surface, this, it does create that. So it's dying somewhere around there. Let me look here. So it's dying before the travel time because travel time is not being output. So I'm going to have it output something to see if it gets here. Okay. So it output that. Oh, I don't have a source 6. So what I can do is, ideally, probably what I should do is the first time through the loop, I should just use source. And then every subsequent time, I should use something else. So I could do that by changing the source after here, and actually all these. So lots of times you have to initialize variables. When you do a loop, one of the skills is to initialize your variables. So I'm initializing source up here as just the very beginning time. So now when it runs through the loop, it's not going to reassign the source again until next time through the loop. And so this will actually have to be +1, right? Is that right? So the first time through, it's just going to be the plain old source. And the next time through, it'll be the same as the output for the last one. So, okay. So I think we found the problem. Hopefully. Still running, so that's a good sign. Yep. So now we're on to the next round. 7. And so now, yeah, you just can go get a Coke and come back, and you'll have your answer. This was the reason that I went over this is that it's a demonstration of the uh, the reason that you'd want to script a process, because some processes require chaining together lots of commands, but not only chaining them together, but logically executing them multiple times in order to get your answer. And so it's not meant to be a comprehensive introduction to Python. That's what the next course does. Well, into programming in general, programming geographic processes in general. That's what the next course is.
Which you should take, everybody.
Yeah, yeah. However you think about the courses here, and me teaching the courses, it is a course that I've had multiple students come back and say, this is a course that that really helped me to get a job. I think more and more often.
Just glancing, a lot of the job descriptions.
Yeah.
Some Python.
More and more often when you go to get a GIS job, at least some programming experience is required. Okay.
So would you recommend Python over Java?
Not necessarily. Java is very important language to learn as well. But the real key, though, is to really understand how it works, because or the logic behind programming. So if you understand when you need to implement a loop, and first of all, what variables are, what a function is, and when to implement a loop, and when to implement an if statement, and how to logically construct things, you can port that to other languages. And so Python is a good introduction to that, because Python doesn't require the same level of kind of setup that Java requires. You can get started in it more quickly, and so Java is a good thing to do. But if you're gonna end up in Java, I would also recommend that you take Python as a step toward taking a Java class. Anyway, yeah, I don't think Java's a bad thing to learn, but I deal with some of the employers down at Stennis, and it almost seems like that eventually we're going to have a hybrid major, that would be the best one for them to hire, is somebody that had some computer science skills and also had some geography skills. And so it would definitely help to take as many courses as you have room for from computer science. But you should be very employable if you've taken 2 or 3 computer science courses, maybe even just 2, and the Python course in order to get a position. But anyway, yeah, it's a good course to take. All right, let's see how this progressed. Did that finish? So now you can see very quickly that I've got all of those data sets. So here's where it gets, it's not 20 months out, but it's 6 plus 20. I got to move the states back down. All right, so here's where it gets after 20 months. 19 and so on. It is moving. Oh boy.
You got weeds in your computer.
Yeah. So it's ArcGIS stopped working, but that's okay because all of this data was created using this script. So even if the data was gone, I could just re-implement that script, rerun that script. This isn't the final script though, is it? Yeah, no, I put source back up there. That's good. Okay, so what I can do is go back here. I'm going to do this in the temporal modeling one, and I'm going to put this on its own page. So modules, and I'm going to call this assignment page. I'll just create a new page for it. I'll call this code to run the model multiple times. So now, if you want to try this, I'm not going to make it a official assignment regarding this code, but if you want to try this, oh, that doesn't work. That works. Okay. So I just took it off of HTML because in HTML it doesn't recognize those tabs. So hit save. So if you, oh, that didn't work at all. Month test. Guess that's it. All right. So now let's see if that works. So I open this. Yep, that works. So now you could experiment with that. You could try to understand the logic a little bit better. You can do whatever you want with it, but there's no formal assignment. If you want to run it for 30 months, you could. Something that would be interesting, like if you want to try it, is to modify this code so that you run the zonal statistics operation that I wanted you to run before, either at the end on the final step, or you could run it on each individual step. So in other words, you'd come down here and create a new data set that does the zonal statistics as table. So you can go, what you could do is every single tool that exists in ArcGIS Pro or ArcGIS Desktop. Oh, it already closed, but if you open up a tool and you hit the question mark, it'll take you to this page where you could say zonal stats as table. All right. Well, here, I'll just do this. So if you open up ArcGIS Pro again and open this tool and hit that little question mark in the corner, you'd get this. You've probably seen me pull these up. But every single tool, if you go down to the bottom, has the Python syntax to execute it. Okay. So here's the Python syntax. I guess this is the Python syntax. And then this is it actually implemented in a script. So if you wanted to, you could execute that. The syntax here is slightly different. So I guess I should do this over here so it gets on the video. So because of this line, you don't have to type arcpy.sa. So if you wanted to change this, you could put that in front of zonal statistics as table. And so what you could do is you could put a line like that right into, I guess it's right here. If you could put that right here, okay? You could save out a zonal statistics table after every step. So for each state, it would tell you how many values, or what the total number. If you did zonal statistics sum, it would tell you the total number of cells for each state were affected. So you'd be automating that second process that I told you to do at the end of last week. And so that's something that you could do to kind of experiment with Python if you wanted to take it that far. So you put a step there, then you would have your output would have a bunch of tables, and every single table would have a line for every state, and it would have a column that would have the zonal sum. In other words, how many cells were affected. Okay, and if you wanted to put all of those into one big table, you could then join those outside the loop. But that might be a little bit more complicated. But it's very doable for y'all to just create that if you wanted to do that. So, all right. Okay. Any other questions? Okay. Great. So for today, just walk through the process that you learn about in taking the ESRI courses and produce two classified maps. Oh, one other thing I just wanted to make sure everybody understands is that in this lab here, when I say turn in a map composition, not a full image. In other words, I don't want your output map. You're gonna create an output raster. Just make a map composition. In other words, what is ArcGIS Pro column? I forgot what they did, but I've had you do this before. But you're basically going to make a picture. You can put them all on the same page if you want. You can put one on top of the other. So I'm just going to hit this guy. Just going to see what ArcGIS calls them. So we've got maps, right? It's a layout, a new layout. So you're going to create a layout, and you're going to put you can put one of your maps here and say maximum likelihood, and one of your maps here and say random forest or something like that. Okay. All right, and then keep your data because we are going to assess the accuracy later. So, and it doesn't matter how accurate you are. Just try the best you can. We're concerned about the process, not necessarily that it's exactly right. Okay, so don't spend hours and hours. Like I said, maybe 1 more hour beyond, or 1.5 more hours beyond what it takes you to do these 3. Okay. All right. And that's it.